These are the notes for 8.6 part 1, and they are on graphing quadratic functions, and you want to make sure and take these notes on graph paper, please. So I've got graphs inserted wherever we're going to need them. You'll have to just draw a graph, so you might have to pause quite a bit on on these notes to make sure you can get your graphs drawn. So the first thing we're going to do is just a pretty simple example. We're going to graph basically the most basic quadratic function there is. So we're going to graph the function f of x equals x squared. So we don't have like a bx or a c on this one. We just have the x squared. So to graph this, let's make an xy chart. So we're going to make this one kind of big just so we can get a really good shape of what this graph looks like. So let's plug in -3 for x. That means we're doing -3 squared. So -3 times -3 is 9. So let's keep going. We're going to plug in -2 for x. -2 squared is 4. Let's plug in -1 for x. -1 squared is 1. Let's do 0. So 0 squared is 0. 1. 1 squared is 1. We're going to go all the way up to +3. So if x is 2, that means we're doing 2 squared. That's 4. And if x is 3, that means we're doing 3 squared. That's 9. So one thing I want you to notice is if you look at these numbers, they kind of mirror each other. It's the same on each side. So just notice that and be aware that that's going to happen in these quadratic functions because it's always going to be symmetrical. So let's plot those points. So I'm going to start with the -3, 9. So I'm going to go -3, 9, -2, 4, -1, 1, 0, 0, 1, 1. Oh, sorry. Sorry, some announcements there. 2, 4, and then 3, 9. So when you draw the graph through this, you don't want to make jerky movements. You want to make it a smooth curve, or just do your best. I mean, mine's not going to be perfect here. So try to make it a smooth curve. It should look like a nice U, like mine's not super great. You want to make it a smooth curve. So this shape that we call this graph is a parabola. So that's the shape of a quadratic functions graph. It's a parabola. It could open up or down, just so you know. It could be like a frown instead of a smile. And the other vocab I want you to know is that this line right here, which in this case is the y-axis, this is called the axis of symmetry because that graph is symmetric about that line. You could fold it over onto itself and it looks the same on either side. So that's how we graph this. You plug in a number for x, find out what y is, and it should look like either a U or a frown. So what I want to do next is look at how we can compare this graph, f of x equals x squared, to if we change it a little bit. So let's look at the graphs of some similar quadratic functions. So for now, just watch. You don't have to worry about writing anything. I'll show you what to write in a minute. I'm going to go on to a graphing program and just show you some so we're not going to graph all of them by making an XY chart. So we are on Desmos, and we have right now, this is the graph of y equals x squared. You don't have to draw this for right now. You can just look. So this is the graph that we just graphed. It's a U shape. It's up. It's opening up, I mean. So let's look at the graph. You can see over here on the left, I'm going to turn on this graph. Oh, I thought I was going to turn it on. Got to go over to my computer. I'm going to turn on this graph of y equals 1/2 x squared. Let me delete that little mark. So there's 1/2 x squared. It's the blue one. So you can see it's still a U shape. It's still symmetrical about this y-axis right here. It still has a vertex at 0, 0, but it's a little wider than the other one. A little wider. So when we put the 1/2 out in front, it got a little wider. Let's try on this next one. We're going to do y equals 2x squared. So let's look at it in comparison to just x squared. So x squared is the red one. If we do y equals 2x squared, you can see how skinny it gets here. It still has an axis of symmetry at the y-axis at the line x equals 0. Still has a vertex at 0, 0, but it's a little thinner and narrower than our original graph of x squared, the red one. Finally, Let's turn that one off. So now we're going to compare to x squared negative x squared. So we have a negative 1 in front. Okay, so if we put a negative in front, you can see that the graph looks the same as x squared, except it flips it over the x-axis. So it flips it upside down. So that's what happens if we put a negative in front of the x squared. So now we're going to write down just what we saw. We're just going to sketch some quick graphs of these. So here's what I want you to actually write. So just make a very simple graph on your page. We're not going to actually plot the exact numbers. We're just going to graph the shapes. If you want to color coordinate this, that would be a great idea. So we've got f of x equals x squared. That's our normal U shape. Ooh, that was a good one. So this is x squared. Now, we saw that when we changed this and did f of x equals 1/2 x squared, it was still a U shape that opened up. But if we put that 1/2 in front, it got wider. So this red one is 1/2 x squared. Then we tried f of x equals 2x squared, and we saw that it was similar to x squared, but it was a lot narrower. So this blue one is 2x squared. And then last, we tried f of x equals negative x squared. And that was the same as the black one on here, just a regular U-shaped curve, but it flipped it over the the x-axis. So this is negative x squared. Pause if you need more time to draw those. Otherwise, I'm going to go on and write a little summary of what we just found. So, in summary, here's what we found. So, the graph of f of x equals x squared is a parabola. That's the shape of it. With a vertex, so that point at the center of the U, of 0, 0. So its vertex is at the origin. And its axis of symmetry, the line that runs through the middle, is x equals 0. It's that vertical line. It's basically the y-axis. So that's one thing we learned. Another thing we learned is that if we're talking about the graph f of x equals something x squared, so ax squared, if a is greater than 0, so in other words, if it's positive, it opens up like a smile. So you can think positive, it's happy, it's a smile. If a is less than 0, so if it's negative, it opens down. So if you have a number in front of x squared that's positive, it's going to open up. If the number in front of x squared, its coefficient is negative, it's going to open down. We also learned about it getting narrower or wider. So if that number in front of x is less than 1, like when we did 1/2, that became wider than f of x equals x squared. If we did a number greater than 1 for a, like when we did 2x squared, it became narrower. You can remember that it's a number bigger than 1 in front of the x squared, so it's getting bigger faster, so it's narrower. All right, just so you know, that was the front page of my notes. I'm now turning to the back, and I've filled up about 2/3 of the back page of my notes. So pause if you need to. We're doing 2 more examples. All right, so on this example, we're going to graph f of x equals x minus 3 squared. So you can see on my graph here, I kind of have it shifted over, so I'm really only showing the first quadrant, and you'll see why in a second. So let's make an XY chart. Now, I know if I plug in numbers that are too small, like -3, I'm going to do -3 minus 3, that's -6. If I square that, that's 36. That is really big. So I kind of want to stay a little closer to home here. So let's try plugging in -1 for x. So if I plug in a -1, that means I'm doing -1 minus 3 and squaring it. So that's -4 squared. So that's 16. Let's work our way up from there. So let's plug in 0. So that means we're doing 0 minus 3, which is -3, and squaring it. So that's 9. -3 squared is 9. I'm just plugging in my number for this x right here. Let's do a +1. So I'm doing 1 minus 3, which is -2, and squaring it. That's 4. Let's plug in a 2 for x. So we're doing 2 minus 3, which is -1, and squaring it. That's +1. Let's plug in a 3. So that means I'm doing 3 minus 3. Oh, that's 0. So I square it, and it's 0. So we know that's going to be my x-axis, because it's when x-intercept. That's when y equals 0. Let's go all the way up to 5. So if I plug in 4, I'm doing 4 minus 3, which is 1, and squaring it, that's 1. And then 5, I'm doing 5 minus 3, which is 2. Squaring it, that's 4. So you can kind of see, like on our last one, surrounding this 0 is the numbers are mirroring each other. So just keep that in mind there. Ah, what happened? Okay, so let's go ahead and graph these points. Oh, I'm on the wrong page. What's going on? Okay, here we go. So let's go ahead and graph these points. So I've got -1, 16. You know what? I'm not even going to graph that one. It's so far off the graph. Let's start with 0, 9. So that's my y-intercept. So 0, 9. 1, 4. So 1, 4. 2, 1. So over 2, up 1. 3, 0. Over 3, up 0. 4, 1. And then 5, 4. So 4, 1. You can see how these points are right across from each other. So we can see that we've already gone down to the vertex, and now we're making our way back up. And then what was our other one? 5, 4. So over 5, up 4. And we can see how this curve is going. I know if I go over one more, it's going to be mirrored up with this. So my next point, even though I didn't figure it out on my chart, is going to be right here. And do your best to draw a nice smooth curve through there. Oh, that one was better for me. So there's our parabola. So we can see here that it looks pretty similar to f of x equals x squared, but instead of having its vertex at 0, 0 right here, it's shifted over 3 units. So we can see that that 3 is coming from there. It shifted this whole thing 3 units right. Its vertex changed. So its vertex is 3, 0, over 3, up 0, instead of 0, 0. So what we want to take away from this is if I'll write this in a little box over here, if we have f of x equals x minus, let's say I don't want to use the letter k, sorry. Let's use the letter h, that's what we're going to use tomorrow. H squared. It's going to shift it h units right. Everything else is going to be the same. It just shifts 8 units right. If I have f of x equals x plus h squared, it's going to shift it 8 units left. It's kind of the opposite of what you would think. If you're adding a number, you actually go left to the x. If you're subtracting a number from the x, you actually end up going right. All right, one more example. So on this last example, we are going to graph the function g of x equals -2 x plus 4 squared. So we can already guess that that 4 is going to shift it 4 units to the left. We know from what we learned before, so this is 4 units left. We know from before that this 2, since it's a number greater than 1 out there, it's going to make that graph narrower than the parent function. The parent function is x squared, just the normal one, the first one we graphed. And we know that this negative is going to flip it upside down. So it's going to open downward, like a frown. So let's make an XY chart here. Since I know it's being moved over to the left, that's why I only ended up showing the 1, 2, 3, third quadrant on my graph, because I know it's getting shifted left and it's going to open down, so I don't need anything really up high. I don't need anything really far to the right. So let's make an XY chart here. I'm going to start kind of low on my x's because I know it's shifted over into the negative x's because of that plus 4. So if we plug in a negative 6, that means I'm going to have negative 2 times whatever negative 6 plus 4 squared is. So negative 6 plus 4, that's negative 2, squared, that's 4, times the negative 2, that's negative 8. And you guys, we just need to be good at that. We've got to be good at doing those mathematics right there. Just that simple stuff. Let's plug in a negative 5. So I'm going to do negative 2 times negative 5 plus 4 and square it. So negative 5 plus 4 is negative 1. Negative 1 squared is 1. And then times the negative 2 is negative 2. Well, we're going to plug in a 4. So I'm going to do negative 2 times negative 4 plus 4 squared. So that's 0 squared, and 0 times anything is 0. So I'm thinking that's probably going to be our vertex, unless it got shifted up or down or something. All right, so now let's plug in a negative 3. So we're doing negative 2 times negative 3 plus 4 squared. Negative 3 plus 4 is 1. Squared is 1. Times negative 2 is negative 2. And look, we can see it mirroring. So I am guessing that my next one is going to be a negative 2. Or sorry, negative 8. So let's start plotting those on our graph. My first point is negative 6, negative 8. So I go over to negative 6 and then down 8. Down to 8. Negative 5, negative 2. So negative 5, negative 2. Negative 4, 0. Negative 3, negative 2. And then negative 2, negative 8. Negative 2, negative 8. So we can see that's kind of skinnier. It did get shifted over to the left. And it's opening down. So everything we kind of expected there. All right, so those are the end of these notes. 17 minutes. All right, that wasn't too bad. Come prepared to do some practice problems.